So task number 7, Socat encrypted shell is part of the What the Shell module, which is a prerequisite for upload vulnerabilities module, which is part of the complete beginner path that we are doing on TryHackMe. One of the many great things about Socat is that it's capable of creating encrypted shells, both bind and reverse. Why would we want to do this? Encrypted shells cannot be spied on unless you have the decryption key and are often able to bypass an intrusion detection system as a result. We covered how to create basic shells in the previous task, so that syntax will not be covered again here. Suffice to say that any type TCP was used as part of a command. This should be replaced with OpenSSL when working with encrypted shells. We'll cover a few examples at the end of the task. But first, let's talk about certificates. We first need to generate a certificate in order to use encrypted shells. This is easiest to do on our attacking machine. Here we see the OpenSSL command. This is a tool. And here we just generate the certificate, as you can see, the shell certificate. This command creates a 2048-bit RSA key with matching cert file, self-signed and valid for just under a year. When you run this command, it will ask you to fill in information about the certificate. This can be left blank or filled randomly. We then need to merge the two created files into a single .pem file. Here we use cat to do this. We basically incorporate the key and the cert in one file. Now, when we set up our reverse shell listener, we use the Socat command OpenSSL with listen on what port you want with the certificate that we just created with the combined certifications and key. And then we say verify 0-. This sets up OpenSSL listener using our generated certificate. Verify equals 0 tells the connection to not bother trying to validate that our certificate has been properly signed by a recognized authority. Please note that the certificate must be used on whichever device is listening. To connect back, we would use Socat OpenSSL local IP with a local port, and then verify 0 exact bind. Basically execute bash. The same technique would apply for a bind shell. We have the target is Socat OpenSSL listen on port with the cert, verify 0 exact command, right, and then pipes. And on the attacker machine, we run this command. Again, note that even for a Windows target, the certificate must be used with the listener, so copying the PEM file across for a bind shell is required. The following shows an OpenSSL reverse shell from a Linux target. As usual, the target is on the right and the attacker is on the left. And here we can see it better. Here we just create a key. You can see it over here. We have it under encrypt key. Then we use cat to embed both files into one. We open on the right the listener on the vulnerable machine and we connect from our machine. This technique will also work with the special Linux-only TTI shell covered in the previous task. Figuring out the syntax for this will be a challenge. Feel free to use the Linux practice box deployable for the end of the room. Figuring out the syntax for this will be the challenge for this task. We see over here a huge result. Feel free to use the Linux practice box deployable at the end of the room to experiment if you're struggling to obtain the answer. Here you see it, a Linux practice box and then a Windows practice box. Answer the questions below. What is the syntax for setting up a OpenSSL listener using the TTI technique from the previous task? Use port 53 and a PEM file called encrypt PEM. Okay, now we copy this command. We go here, paste it over here, and then we open again. We open this command. And we paste it over here. Now, let's see. For this one, we have OpenSSL listener on port 53. The file is a TTI Socat port, and then we remove these and we leave only, yes, this should be the command. Let's see. Okay, something, actually the file is called encrypt.pem. Submit. All right, it's not liking something. Raw. Let's see. Okay, so is this okay? Now after this, if your IP is 10.10.10.5, what syntax will you use to connect back to the listener? Instead of TCP is OpenSSL. It's OpenSSL. 10.10.10.5 53. Cool. So basically the command is from, we have to use this one to connect back. And then we have to change the service, OpenSSL, our IP and the port that we listen on. That's it.